morning, students. Today we are going to learn the next part of the chapter, calorimetry. The topic is calorimeter, which is an instrument which is useful for measuring heat. Okay, heat absorbed or heat released can be measured with the help of a calorimeter. Now, we will first learn about the construction of calorimeter. It is on page 265 of your textbook. A calorimeter is a vessel. You will see it is a cylindrical vessel like this. It is made up of this much size. We have calorimeters in our lab. Calorimeter, you will see this is a vessel and it is copper. Okay, why is copper chosen? Copper is a good conductor, first of all. So it will absorb heat very easily. And second thing is that it has low specific heat capacity. So low specific heat capacity. This is the another reason why copper is chosen. Whenever we are heating it, quickly it will show a rise in temperature. That is what you mean by low specific heat capacity. So quickly it will show. Supposing I am filling water in it, quickly the water will get boiled. So that in your mother's kitchen, you might see some vessels which have copper base. Base of the vessel is a copper. Okay, so maybe a vessel where you cook vegetables, which is in Indian language we call it as a kadhai. So it has copper base. Why? Because in copper base, heat can be absorbed quickly. Now, this vessel is polished from inner walls as well as the outer walls. Why? Because when the heat is inside the calorimeter, if it is polished and the heat is trying to escape out, because of the polish it will enter back. Okay, polished surface will not let the heat escape out. So whatever heat has entered, if through the walls it is trying to escape, will be returned back. If little bit also escapes, here outside wall is also polished, so again it will enter back. That's why the inner and the outer walls of copper are polished. Okay, now with time the polish it will be less and all that, so you need to repolish it. Okay, now what is done after this? This whole arrangement is basically to avoid any loss of heat. Now after this, what is done is, there is some insulating material like wool or cotton which is kept around it. Okay, so around it there is some insulating material like wool, copper, okay, woolen fibers are kept. Now to avoid any heat by conduction, so it is not directly touching anything. Okay, then now it is kept in a wooden case. Okay, so this is a wooden case. It is kept in a wooden case, and the wooden case here, okay, it has two slots. One slot is for a stirrer. A stirrer is like a spoon. It will stir the contents inside whatever we are trying to heat. And one slot is for your thermometer. So this slot is for the thermometer and this slot is for the stirrer. I want you to look at the diagram 11.1 when I am explaining this. Okay, so parallel. So now here what happens is that we are avoiding any heat by convection, we are avoiding any heat by conduction. 100% radiation cannot be avoided. Okay, so these are the measures taken basically. Now what is the principle on which the calorimeter works? Calorimeter works on the principle of heat lost by a hot body is equal to heat gained by a cold body. So heat lost by a hot body, okay, because see, supposing I have one hot body here, this is a hotter body, comparatively this is a colder body, and I touch the colder body to the hotter body. Temperature gives us the direction of heat passing. That is what we have learnt in last videos. So heat will go from hotter body towards the colder body. So heat will be lost by the hotter body and will be gained by the colder body. We are not thinking about heat losses. Okay, we are thinking heat losses are not there. So ideal conditions. Okay. So heat loss by a hot body is equal to heat gain by a cold body. Okay. So now this is given on page 11.12 equation on page number 266. Just mark it, note it. Okay. So this is according to the law of conservation of energy. Okay, remember that, because in this law of conservation of energy, heat lost by hot body is equal to heat gain by cold body. There is no losses to the environment. Okay, we are thinking of an ideal condition. Heat loss is equal to heat gain, that is energy is conserved. So law of conservation of energy is followed here. Okay, so this is basically what is a calorimeter. Now we are going to learn a mathematical statement which will be helpful for us to solve the numericals which are there in the calorimeter. Okay, for that we will go for the next video.